Hello again, welcome back. What I want to look at today is capacitors and capacitance. And what I've done is to begin to look at how a capacitor charges and discharges. Now I have a diagram here which shows you how if you put this switch into position 1, it will charge the capacitor. But it will charge the capacitor to the maximum applied voltage. So if it's 9 volts, it will charge to maximum of 9 volts. If it's 12 volts, then it will charge to a maximum of 12 volts. Once you take the switch off, that capacitor will hold its charge. Now if you put it into position 2, it will discharge and you'll see the lamp light. Okay. Now again, draw these diagrams out for yourself. Get familiar with how the circuit works. Try it for yourself. It works. Okay. Now, be aware that you need to write out information that you can see here. Write it out, make it your own. Don't assume to read it from the screen. That will not always work. Okay? And excuse me, I have a cold. As you know, winter is here, so everybody gets a cold. Capacitors. All of us now, here I've given you an explanation and an illustration as to how the electrostatic electricity which appears from combing your hair simply can actually produce an effect. Now the effect is actually produced by the movement of electrons from one side to another. So you have a buildup of electrons on one side and a displacement of electrons from the other side. Okay? But again, read the information, make it your own, extract it, take the time. You cannot just glance at it. Now this is for you to read for yourselves. I don't need to read this to you. Okay, again. Okay. Now if I have time, I will tell you a little story at the end while making this video. Again, read information, pause it if you have to, look at it, extract it, deal with it. Okay, that is your job. Now here again, I've given you a couple of little experiments that you can do. These experiments work, believe me, I know, I've tried them myself. They actually works. Now, again here you can see a green diagram of north and south, how unlike poles attracts and like poles repels. Okay. Okay. Now draw out the diagram. Make sure you can read the information that I have given you. Make that information your own. You'll see how it becomes quite applicable. Now charging current. Now when this switch closes, the positive terminal of the battery is 5 volts more positive than the plate. Now again, be aware that you're charging a capacitor, so on one side there will be more electrons than there is on the other side. That's all it is trying to say. Okay? Now write out the information, extract it, do some ground research for yourselves, get familiar, provide research. Knowledge is information, information is knowledge. Use it. It tells you here exactly what is what and what effect happens to plates A and B. Draw it out for yourself, get a better understanding of those plates. Here is the charge and discharge graph of a capacitor. Okay, and you'll see that there's a moment in time when both the rising charge and the dissipating current crosses each other. Now again here, be aware of the Greek symbol. Look at the formulas, write out the formulas, make sure you understand what each letter represents. Don't take it for granted that you will recall it from the screen. That will not work. Okay? You must make the information your own. And again here we're talking about dielectrics. Know what the dielectric is, know how it's meant to work. Remember that the dielectric is a material which is inserted in between the plates of a capacitor, no matter what those plates are made of. Permittivity. Okay, again, get to know the understanding of that, its symbol. Now again here, read the information. You don't need me to be reading this for you. You're quite capable of reading this for yourself. So read it. This shows in the diagram how the plates in regards to a capacitor, how it is folded up, and how the paper, wax paper, is insulated, is inserted in between the foil that makes up the capacitor in this case. Do some groundworks, do some additional research for yourselves. Get to know how your capacitor works and the handling voltage variability of each capacitor. Here we have relative permittivity. Keep that in mind. You need to read that for yourselves as well. Bring it into play. Remember that it has a constant value. Okay. And I've done an example here for you. So read the example, write it out, make it your own. Write out the formulations. Bring those into play. Okay. Make this your own. Make sure that when you put into your calculator you get the same answer that I have. And remember that you're dealing with microfarads, nanofarads and picofarads. Each has their own values in regards to the minus factors. -6, -9, -12, etc., etc. Okay. And here we look at the multiply capacitors. And again, the formula for that is somewhat different. Remember the formula, write it out, make it your own. Do the calculations that I have done. Now, that is it for this section. I have used information from F. Goodall and D.K. Richton. Now, please note that these are books going back to 1977, 1987. I doubt very much they're in publication now. But again, thank you for viewing this video, and I hope we will see each other again in due course. Now, let me just go back a little bit. Now, I actually recorded this before, but my mobile phone went off right in the middle, in the last 10 seconds. And although I tried to edit it out, I just could not get it removed. So I've had to do this now for the second time. You can imagine how annoying that is. Anyway, I hope you enjoyed the information I have provided, and we'll speak again soon. Thank you. Bye-bye.